Okay, page 11, 3 more problems. Rectangles perpendicular to the y-axis. So here, perpendicular to the y-axis. Now keep in mind, these are just examples in the notes, but the issue here is that you'd be given the problem more like this and not with this right here. So when we're dealing with perpendicular to the y-axis, this is just so we remember. So perpendicular to y is going to be x is equal to, and this would be dy. So this is important to remember. So it says, let R be the region in the first quadrant. Okay, that sounds important. In the first quadrant, bounded by the graphs of y is equal to the square root of x and y is equal to x over 3. Let's see. For the solid, the cross section is perpendicular to the y-axis, and the rectangles whose height is 5 times the length of its base. Whose height is 5 times the length of the base. And the length of the base is on the base of the solid. So when you have, let's see, perpendicular to y, that's actually going to be right minus left. So that area needs to have something sitting on it. So remember, a rectangle has a long side and a short side. So that means the longer side will be on the paper, filling in the area between the two curves. So what I need is sketch of a graph. So here, the square root of x is going to go something like this, right? And then we actually have a linear function, but it's going to be super duper flat because the slope is 1/3. So that means it's going to take forever for these two to cross. So again, this is just a sketch, so I'm going to have to take a look, find out what my bounds are. Okay. I want something like this and like this. Okay, so we know that this is y is equal to the square root of x. Y is equal to x over 3. So we need to figure out which function which function is on the right and which one's on the left. And this is the area between the two curves right here that we're looking at. Okay, not doing a very good coloring job. Sorry guys, I went outside the lines. But we need to figure out which one's on the right and which one's on the left. So once we do that, we designate what's on the right and what's on the left. We can then manipulate the equation to determine what they are in terms of x. So we can write them as x equals, because right now they're in y equals form. So it appears here that the linear is on the right. So we have y is equal to x over 3. So that means y is equal to the square root of x has to be on the left. So if we manipulate these to write them as x equals, I'm going to multiply by 3. So here's 1. And then here we would square, so x is equal to y squared. Okay? So now what we also need are our bounds. So if we're doing right minus left from bottom to top, my bottom here is going to be at 0. What I need to know is, what is the y value for this right here? So if I were to set these two equal to each other, okay, they're already in form. I solved each one for x. So you have 3y is equal to y squared. Subtract. So now factor out, y minus 3. So we're saying that y is equal to 0, which we got here, and y is equal to 3. So that means my upper bound is 3. So now I have my bounds. So here are my bounds. Okay, so now I have my functions, which is going to be right minus left. Here I have my bounds from bottom to top. And now what we need to do is use our rectangle area formula. So the area of a rectangle is base times height. They told us that the height is 5 times the base. Okay, so I need to make the substitution. Area is equal to 5b squared. Okay, so this is going to be the area formula that I'm using based on the information that they gave me. The right minus the left is now actually going to represent my b. So before, just depending on the formula, it could be a d or it could be an s if it's the side or the diameter. So it just really depends on what you're using. So my b, in this case, is equal to right minus left. So this is 3y minus y squared. So since I'm allowed to use a calculator for my final answer, I actually just need to provide the integral. We have the volume is equal to, there's my constant, 5 times the integral from bottom to top. Okay, so from 0 to 3, my base is 3y minus y squared, but I need to square it, and this is dy. So here's my integral. Now all I need to do is go into my calculator and type this in. Now remember, when you're using your calculator, the variable that we typically use is x. It doesn't matter what the variable is because I've accounted for the adjustments in the way the function is set up. So we have 5 times the integral from 0 to 3 of 3x minus x squared, which this is really y, squared, which is this, and then I have dx because it's a variable that I used. So there's my area, 40.5. So then I would say, or excuse me, volume. My volume is equal to 40.5 cubic units, whatever that is. Okay, so the last two, again, are with respect to or perpendicular to the y-axis. It says the region R is in the first quadrant, bounded by the x-axis. Okay, first quadrant, bounded by the x-axis. And the graphs of y is equal to 2 minus x cubed and y is equal to the tangent of x. The cross sections are perpendicular to the y-axis and a right isosceles triangle with the base as the hypotenuse, and we want to find the volume. Okay, so a couple of different things. First of all, perpendicular to the y-axis means x equals something dy. Currently, these are not in that form, but I need to know what the graph looks like, so this is okay. I'll put these in the calculator, and I can also find my bounds. So there's a couple things I can do. It doesn't matter what you do first, but I do need to say, okay, how do I find the area of a right isosceles triangle with a base as a hypotenuse? So that area is equal to 1/4 s squared. Okay, so if we're talking about perpendicular to the y-axis, that means right minus left. So this s right here is going to be my right minus my left. Okay, so s is equal to right minus left, and we need to figure that out. So we're going to go into our calculators, clear out the functions that we have in y equals, and we'll put these two functions in. So we've got 2 minus x cubed and the tangent of x. Now I'm not going to be able to use these once I manipulate the equations, but this is going to help give me my bounds. I'm not going to change the window. I'm going to see if this will give me what I need. Oh, actually it does. Okay, so here's my graph. So I'm going to sketch it over here. Okay, so it goes like this and like this. And based on which one graphed first, 2 minus x cubed, graph it again. Okay, so this one is y sub 1, this is 2 minus x cubed. And this is the tangent of x. Okay, so that way I know. And it says that they want, in the first quadrant, oh, bounded by the x-axis, so it's right here. So they're looking for this right here, this region. So that's region R. Okay, so on the calculator they're looking for this. Okay, so if I have right minus left, it's going to be, my right is the 2 minus x cubed. So right is y is equal to 2 minus x cubed, so that means the left is y is equal to the tangent of x. Okay, so that definitely helps me because I need to manipulate those, and then I need to find the bound. So the first bound over here from bottom is 0. I need my y value to top here, so I need to find this point of intersection. 5. There's my cursor. Enter, enter, enter. So this is 1.2657. Okay, so now I have my bounds. I need to manipulate these, and then I think I'm ready to go. So to solve for my right side, subtract 2, divide by a negative, take the cubed root. So you have x is equal to the quantity of 2 minus y to the 1/3 power. Okay? And then here, x is equal to the inverse tangent. of y. Okay, so for my setup, for my volume, I've got the volume is equal to 1/4 on the outside from 0 to 1.2657, and then my side, which is my right minus my left, S is going to be equal to the quantity of 2 minus y to the 1/3 minus the inverse, tangent of y. This is my side. It's going to go in here. Okay, so what we have is 2 minus y to the 1/3 minus the inverse tangent of y squared dy. This is my integral. This is what I would need if I were being tested for the setup. So now what I'm going to do is plug this into the calculator, just exactly as I see it. So I need to go into my home screen. Let's see, 0.25 times the integral from 0 to 1.2657, and then I need to be careful when I'm typing here. So let's see, parentheses for the whole thing to be squared, parentheses 2 minus x to the 1/3 minus the inverse tangent of x squared. Just watch your parentheses. I hope that worked. Give me an error. Nope, that's right. So this volume is 1.46. Oh, no. This is not 1.4, but 0.15. So it's 0.1468. Okay, one more problem. Hang on. Okay, so we need to find the volume. I'm ignoring this right here because you'd be given a problem like this. We're going to find the volume of a solid whose base is enclosed by a circle. Okay, so we have a circle whose cross sections are taken perpendicular to the y-axis and are equilateral triangles. Okay, so a couple things. Perpendicular to the y-axis means x is equal to something dy, so we're going to have to solve this for x, okay, which means I need a right minus a left, and my bounds are going to be from bottom to top, okay, perpendicular to the y-axis, equilateral triangle, so the area is the square root of 3 over 4s squared, because we used this already on the previous page. Okay, so what I need to do first of all is sketch my circle. So I'm going to sketch a circle. Okay, in this case, my center is at 0, 0, and my radius is 2. So we'll do our best to make it look like a nice circle. Remember, it is a sketch, just so you can get an idea of, oh boy, it's going to be bad. Of what our right and our left is going to be. Okay, so this is my lopsided circle, and what we're going to have is a right side minus a left side. Okay, and I'm hoping that you can see that your bounds are going to go from bottom to top, and in this case it's going to go from -2 to 2 because of my radius. Now I just need to solve this for x. So we have x squared is equal to 4 minus y squared. Take the square root. X is equal to the positive square root of 4 minus y squared and the negative square root of 4 minus y squared. This right here represents the right side. This represents the left side. So we're going to have right minus the left, which in this case is going to represent my s. So this right here is my left. This is my right, because it's the positive. And then the combination of your right minus your left is going to be your side in the area formula for the equilateral triangle. So S is equal to right minus left. So S is going to be the square root of 4 minus y squared minus a negative square root of 4 minus y squared. So here we actually get 2 times the square root of 4 minus y squared, which is my S, which goes in right there. Okay? Alright, so now we have volume is equal to the square root of 3 over 4 times the integral from -2 to 2 of the quantity of 2 times the square root of 4 minus y squared dy. Now in this case, you could actually do this by hand, but why when it says we can use our calculator? So I need to type this whole thing in. So we've got the square root of 3 over 4 times the integral from -2 to 2 of the quantity of 2 times the square root of 4 minus x squared dx. There we go. So my volume is 18.4752.